So 7.4 is logarithmic equations. The other part of 7.4 is inequalities. We're not going to cover inequalities. We're just going to cover logarithmic equations. And for the most part, these are going to be pretty straightforward. What our goal is going to be is to be able to make the same log base on each side, and then you just solve for the other part. For example, and then there's also going to be ones where you rewrite and you solve for x. So this first example, you're going to have problems of this type, where they've given you two of the three things that you need in order to solve. So what I want to really do is rewrite this equation as an equation without the log. So how would I do that? 9 to the 3/2 equals x. So that's all you really need to do here. Simplify that, and you're done. So go ahead and finish that problem. You should be able to do this without a calculator very easily. Okay, make sure that you rearrange this and write it properly. We know with exponential powers, what is the denominator equal to?
The root.
The root. This is the root. And 3 ends up being the power. So you should be able to do this without a calculator. In fact, you should be able to do it quicker than with a calculator. Okay? Alright, square root of 9. What's the square root of 9? 3. 3 to the third. 27. Okay? Just looking around, you all had that. So that's good. Okay? That's going to be one type of problem that you're going to see. They're going to give you two of the three parts. You're going to rewrite it without the log, and then you're going to solve. Okay? That's part of what you're going to be doing today. The other thing that you're going to be doing today are equations that have logarithms on both sides, like this. Okay? Now, the types of problems that you're going to see are going to vary. But notice here on each side, it's log base 3 on each side. And there's only one thing, and notice why that's in parentheses. Okay, this is all the same thing. It's all one. It would be like the 2x being one thing, x squared minus 15, one thing. So what the types of problems that you're going to have the log base being the same on both sides, and then it's just going to be a matter of setting those two things equal to each other. Because in order for the logarithms of both of those to be equal to each other, what I've highlighted in red also has to be equal to each other. Okay? So you end up with this. Now, what kind of equation is that? Eventually, what's the name of the equation? Quadratic. How do you know that it's a quadratic? Highest power is 2. Okay, so which means you have to say quadratic, subtract 2x from both sides. So go ahead and do that. You can either factor it if it's factorable, or you can use the quadratic formula. I would use one of those two. So go ahead and finish that one. Hopefully you had that. How many did? Okay, good. Now, here's the one thing that I have to caution you on, and something that you're going to need to do, is sometimes, especially with quadratics, we introduce factors that will actually not work, or solutions that won't work. So what we are going to have to do with logarithms is check our answers. Okay, yes, you're going to have to do your check and show your check, because sometimes it will have created an answer that actually is not an answer. So in this case, that's going to happen here. One of these is not going to be an answer. So I go through with my check, okay. So let's start with 5. Okay, I put it all here for you. I plugged 5 in. 5 squared is 25 minus 15 is 10. Plug 5 in over here. Log base 3 of 10 equals log base 3 of 10. So we're good there. So x equals 5 is going to be a solution. No big deal there. Go ahead and plug negative 3 in, and you do that check. Okay, and see what happens there. Make sure that when you do your check, you plug it into the original equation. Okay? If you just plug it into the equation that you had as the quadratic, it's not going to help you. You have to plug it into the original equation. Look here. what can you raise 3 to equal 10, it's going to be a crazy decimal. We'll get into that here in a little bit in this week, so we can figure out what that number actually is and how to simplify that. But I can raise 3 to a power to give me a positive. Both of these are positive, so we're okay. So you would think, after you plug it in, you look at it and you're like, okay, well, they both equal log base 3 to negative 6. Then it works. Well, let's understand what that means. Okay? What that means is 3 to some power equals a negative number. What number can you raise 3 to turn it into a negative? So if I take it to a negative power, that really just means move it down to the denominator. That doesn't change it to a negative. Any positive power is going to be obviously bigger than 3. Fractional power, still not going to turn it to a negative. Okay? In other words, there's no way to take 3 times itself whatever number of times and it turns into a negative. This is a problem. This doesn't work. Okay? And in fact, the other thing that we talked about when I introduced logs is you can't have negative numbers here or here. It can equal a negative, but these two numbers can't be negatives. They have to be positive. So what that means is we have to throw that answer out. Question, that's the biggest thing. And my only answer is x equals 5. Okay, so this is important to note when you're doing your check. Now, don't think that that always means if your answer comes out to be negative, you're going to throw that one away. It is possible that you can have a positive answer that will still force what's inside here to be negative, which again will create a problem. Which is why you have to check them every time. Okay? Questions on any of that? Does that make sense?
What is the 3 equal to 10 in the first one? 5.
It's going to be a decimal. Okay, so that remember, when you have this, one of these being a negative, obviously the problem will start off with whatever the base is, and it won't be negative. But if this ends up being negative after your check, that's where you have a problem. Okay, because that can't happen because of this. Other questions?